Welcome back. This is the fourth section of the Hands-on Shaders and Particle Effects in Unity 2019 course. In this section, we are going to talk about the particle effects part, namely the new tool called VFX Graph. After checking out the main differences between Shuriken, the current particle system, and the new VFX Graph, we are going to create a couple of cool-looking effects. So let's start with the theory part and see what the VFX Graph is all about. VFX Graph, or VFX Graph, is the new particle system. The main difference from the regular particle effect is that it runs on GPU instead of CPU. It brings many advantages, the performance being the most obvious one. While the CPU particle system can run thousands of particles, the GPU particle system can run millions. Also, it is possible to run complex simulations like fluid systems on GPU. However, the new system has some drawbacks as well. The most noticeable one is that it cannot directly interact with the game world. Well, it actually can have some interactions, but the process is super heavy and it is not worth it. The reason behind it is that the physics system runs on the CPU, so it is easier to use the old CPU system instead. As you can see, the VFX particle system is not a substitute for the Shuriken system. Unity is planning to add support for CPU particles to the VFX graph. Until that day, however, both of the systems have their use cases. Just like other SRP-compatible elements, the VFX graph is highly customizable. You can create custom functionality with C# scripts, and you don't have to wait for Unity to release new features for the system. It is easily extendable. One of the most important additions is the ability to use data types like point caches, vector fields, and sign distance fields. They can be exported from external software like Houdini. So let's install the VFX Graph package from the package manager and take a look at it. After the installation, create a new VFX Graph from the Create Visual Effects menu. Double-click to open it in a new window and dock it somewhere. As you can see, the window itself is pretty similar to the shader graph window. We have nodes and a blackboard for exposing variables. The top buttons, however, are different. The Refresh button refreshes the graph in the scene. Select Asset selects the graph asset in the project. Blackboard toggles the blackboard window. Target Game Object button toggles the Target Visual Effect Game Object window. It allows you to select a game object from the scene to preview the current VFX graph. Autocompile, as the name suggests, turns off the auto-compilation of the graph. You may want to disable it if you have a huge graph and the process takes time. You can compile it anytime you want by clicking the Compile button. Now let's check the system itself. It has some components break down to specific areas. These areas are called contexts. Each context is responsible for a specific part of a particle's lifetime, namely spawning, initializing, updating, and rendering. The context areas are being processed from top to bottom and can have extra blocks. These are similar to the nodes but are specific to each context and executed from top to bottom. Notice that some of the blocks can have inputs. You can provide those inputs using nodes, and they are pretty similar to the shader graph. One thing to note here is that a single graph can contain multiple contexts of the same type. So this is it for the introduction part.